Welcome. Hey, how's it going, everybody? So this is the last set of videos for this year. You should be happy on the inside. The downside to this is that this could be a very long video. We have quite a bit to cover in this first part. We're actually going to cover the first 3 pages of the notes. All right, and some of the stuff is not there. So when you're ready, I'm ready. Ready? Okay. So the first part of this is what's called here the Binomial Theorem. In order to know the Binomial Theorem, we have to first know some background information before we can get there. And this is the first part. And this here's a definition of evaluating this piece here. The way I say this right here, it would be n choose j. So to find that out, I would have to do this lots of math. And in thinking about this today, with the amount that we have to cover, I'm not going to go over what a factorial is. That's what the little exclamation mark is. I'm not going to really do that. I'm going to just show you how to punch it in the calculator, and we can get to the factorial part. You know, you can get to that as far as later. Just, you know, type of a thing. Okay? So here we go. Bonk. So it asks me to find each of these. Okay, so again, the way that I do this or say this is I say 4 choose 1. So how do I do this? Well, in my calculator, what I'm going to be looking for is what's called a combination, because that's what this is called. It's called a combination. It's part of my probability. And what you're going to make your calculator look like is this. 4 NCR 1. 4 choose 1. So how do I get this symbol into my calculator? Glad you asked. So now I come over here. And I go to my calculator. And the way I do this is I put in the 4 first. You always put the number in first. I go to my math button right over here. Press math. I tab over to where it says probability, PRB. That's this over here that you can't really see too well. And I see here it's the number 3. So I just click 3. Make. Choose 1. Enter. I get the number 4. Woo! That's exciting. So I hit go back to where I was at. And when I do this, I come over here and I say, well, this is equal to 4. Well, what does this really mean by 4 choose 1? What this is saying is I have 4 things. And I wanted to find out how many different ways are there for me just to choose one of them. It makes sense that there's only 4 ways for that to happen, right? I choose that one, that one, or this one. There's only 4 of them to choose from. So what happens on this next one here when I say, hey, I have 5 things and I want to choose 3. How many different ways can I pick up 3 things from a set of 5? Ooh, that's a little bit more complicated. So again, I come over here, calculator. I set up and I do the same thing. I do 5, math, tab over to probability, hit the number 3, choose 3. So 5 choose 3, enter, 10. Calculator tells me there are 10 different ways that can happen. Okay. And that would normally be great, and that's fine. And I'm okay with that. So what I want you guys to do, again, is the button strokes. I'm going to just tell you guys, hey, I want you to pause this real fast. And what I want you guys to do is write down the calculator part. So for instance, the calculator part I'm looking for B is where it would be 5 NCR 3. I'm looking for that for C and D. Okay? I think that's actually, I'm just going to skip that. We don't need to worry about that. If you were to put those into your calculator, okay, if I was going to do 7 choose 5 things, hey, guess what? there's 21 different ways that I can choose 5 things from a group of 7. And number 10, or D, is the kicker. How many different ways, if I have 50 things, I got 50 marbles, and I want to choose 35 of them. And I can sit there and count all the different groups. Like all these here, part A, B, and C, I can count out groups of them. You know, I can easily count 21 things. But how many different ways are this? Okay. This is the hard, that's the amazing part. This is 2.25 times 10 to the 12 ways. Huge. Okay. It's like 2.2 trillion ways. There's no way you can count all those out. Pretty cool, huh? All right. So next thing on our list. They didn't actually provide a slide for you. So at the bottom of page 1, you have quite a bit of white space, or at least you should have quite a bit of white space, unless you've been doodling already. I need that white space. All right? So in this white space, what I want you to do is we're going to create something. So create a line. So up there at the top, or right there, make a line. And we're going to create what's called Pascal's triangle. This great guy named Pascal came up with this triangle idea. His idea was this, was that if I put the number 1 here, and I put another, my next row, I put another 1 and another 1, and then the third row, I put another 1, but in the middle here, I'm going to add up these 2 numbers. So 1 plus 1 is 2, and I put another 1 to finish it. So I start each row with a 1, I add up some things. So first off, I put 1 here, 1 plus 2 is 3. 2 plus 1 is 3, and I finish it with a 1. I do the next row, 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Finish it with a 1. 2 more rows and we'll be done. 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1, bink. 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And 1. Woo! You will need this. Okay? You'll need this for your homework, and you will need this for, like, you know, next problem that's coming up here. Okay? So keep this handy. You might want to put, you know, a little star. Okay? Same thing. Need. All right. So let's take a look how we're going to use this and need this. So when I do this, I come over here next. All right, so let's use Pascal's triangle to expand this. So how does this work? So Pascal, he made this triangle. He's like, hey, this is kind of a cool triangle, but how can it be used? And somebody said, hey, if I have this, a times b to the 6, oh dear God, and I want to multiply it very quickly, because remember the slow way of doing this. Okay, the slow way of doing this, if I want to expand this out, this is where it's going to get crazy. I would have to do a, right, a plus b, now don't write this down, you don't need to, times a plus b, times a plus b, times a plus b, times a plus b, times a plus b. You'd have to FOIL this, get an answer. FOIL this, get an answer. FOIL that, get an answer. Take your answers and do more foiling. Take your answer, do more foiling. Combine everything together. It's a pain in the butt. So Pascal came up with a really cool way in using his triangle. Here's how this works. First thing you do is you take a look at the exponent. Here's Mr. Exponent. You find out, count out the rows that you are there, and those are the rows that you're going to use. So in this one is row 6. This is the one that starts 1, 6, 15, 20. Okay, that's that row. And this is how it works. I write down the first number that's there. What's the first number? Everyone say it. You're right, it's 1. And then I take the coefficient a, the first thing that's there. I'm going to be multiplied times a to what power? I'm going to say to the 6th power. And then I take the b, and I multiply it to, or take it to the 0 power. And I do plus, And I do the same thing. What's the next number in Pascal's triangle in that row? 6. And then I take a, and this time I'm going to reduce this power by 1. It's going to be a pattern. B, I gained that pattern by 1. And then I do the same thing. I repeat, 15. A to the 4th. B squared plus 15. A cubed. Oh, not 15, excuse me. 20. A cubed. B cubed. Plus, now I go backward. It's 15. A squared. B to the 4th. Subtract the 1, add the 1. Notice every single time my exponents always add up to 6. Okay, see if I don't think I have enough room here. Plus 6. A to the 1st, B to the 5th. I go down here and put plus 1. A to the 0, B to the 6th. And now I simplify. First thing is, a to the 6th is 1, that's a to the 6th. Plus. Oh, what happened to b to 0? Anything to the 0 power is 1. So here I have a to the 5th, b to the 1st, but with a 6, so I do 6, a to the 5th, b to the 1st. Plus 15, a to the 4th, b squared. Plus 20, a cubed, b cubed. Plus 15, a to the 4th, b squared. Oops, I screwed that. I messed that one up. A squared, b to the 4th. Plus 6, a to the 1st, b to the 5th. Notice you don't have to put the 1 right there, right? Plus 1, now again here, a to the 0 means just times 1, 1 times 1, b to the 6th. And there's my answer. And I can argue, and I'll argue quite successfully, that even though it was completely painful in the sense that it took forever and there's a lot of writing stuff down, is a whole lot easier than doing all this foiling and then all the combining. No, much easier. And that's what Pascal did. He kind of created the kind of first calculator. Everyone was wanting to do this binomial expansion of stuff. They just grabbed out Pascal's triangle, flopped it down, and started doing their work. Okay? So then I go over here and I'll find out what's next. Alright. Alright. So what makes this one different? This one, instead of having just an a and a b, has a 3x plus a 2. And again, I'm going to the 5th power. That makes it a little bit different. So you guys should be going to the 5th line. So again, so how does this 5th line work? My 5th line on this one, start off by saying 1, because that's my Pascal line, right? This time, what's a? Well, a is this business right here. And b is this business right here. So, instead of writing a to the 5th power, I write 3x to the 5th. Instead of b to the 0, I now have 2 to the 0. Plus 5, 3x to the 4th, 2 to the 1st, plus 10, 3x to the 3rd, times 2 squared, plus 10 3x squared, 2 cubed, plus 5, 3x the first, 2 to the fourth, plus, still running out of room, 1, 3x to the 0, 2 to the fifth. And again, where did I get these first numbers? These first numbers all came from Pascal's triangle, from the fifth line, and now I just multiply. And what am I going to be multiplying? I take 3 to the fifth right here, because it's going to be 3 to the fifth times 2 to the 0. Again, this is just going to be a big giant 1, so I don't care about it. And there's a big giant 1, so 3 to the fifth is 243. X to the fifth power plus, on my calculator I would do 3 to the fourth, which is 81, times 5 times 2 to the first power, and that would get me 810 x to the fourth plus, and then I do 3 cubed, that's 27, times 2 squared, which is 4. So 27 times 4 times 10 gets me 1080 x cubed plus 3 squared is 9, 2 squared is 8, 8 times 9, 72 times 10, 720 x squared plus 5 times 3 times 16 is 240 x plus 1 times, remember, big giant 1, 2 to the fifth is 32. And there is my answer. Ta-da! All right. Now, normally this is the part where I'd say this is your turn and go on, but I am going to skip it because you guys already sat through a lot, and it is time to get moving. So this would, part C, the number C, this would be yours. If you would like to do it and set it up, you can, but I'm not going to do it or show you the answers because we just need to move on. The one I want to do last as an example for you, not last over this time through, but this example, is this one right here. And again, what makes this one different? What makes this one different is the negative. That's what makes it different. What is that different for? Okay. This one is different because there's my A, and right here, how am I going to do the negative 2? Well, a negative 2y, I changed it to plus and negative, there's my B. So again, we're going to the sixth line of Pascal's triangle. Okay. And you're going to write this out. Okay. So again, here we go. 1 times x to the sixth times, let's make that smaller because we're going to need the room. So I'm going to go all the way over here. Okay. X sixth negative 2 to the negative 2y, excuse me, to the 0 power. Okay, plus, let's see here, 6x to the fifth, negative 2y to the first, plus 15 x to the fourth, negative 2y squared, plus 20 x to the third times a negative 2y to the third plus 15 x squared, negative 2y to the fourth plus 6x negative 2y to the fifth plus 1x to the 0, negative 2y to the sixth. So how is this going to be different when I start combining things or start taking exponents? So this first one is going to be the same, just x to the sixth. the whole thing goes to 1, plus. Well, in this case, here I have a negative 2, so this is where I gotta be cautious. It's not going to always be a plus. So anytime that I have an odd power, this whole coefficient part is going to be negative. So negative 2 times 6, it's a negative 12, x to the 5th, y. Okay, even coefficient on the y, so that means it's going to be plus here. 4 times, that would be 60, x to the 4th, y squared. Odd coefficient for this one, so that means it's going to be negative, 160, x cubed, y cubed. So now since this is an even one, exponent for this negative one, I'm going to get a positive 240, x squared, y to the 4th. And then the next one, since it's negative, I get a negative here. This is an odd exponent, and it'll be 192, x, y to the 5th. And last but not least, that's a big giant one, that's a big giant one. Negative 2 to an even power is going to be plus a 64y. And that's my answer. Woo! Huge again. But easier. I mean, easier than multiplying it all the way out. Okay? It's 2 steps. They're long steps, but it's just 2 steps. It's not difficult. Again, part E here, because of the length of the time on this one, if you'd like to go ahead and do this one, I'll have the answer available to you in class. Okay? And you can come in and see what this is. I do have to cover one more section. Okay? And this part here, when I looked at it for the formula for binomial coefficients, it's a lot of gibberish. So I just came over and I said, let's try and make this as simple as possible. So when I try and make this as simple as possible, the types of questions that you would get for this is find the coefficient of the 4th term in this expansion. So here we are, and you're going, oh my God, no, mister, no, not the 10th level of Pascal's triangle. No. After looking at this, Pascal took a look and said, you know what, there's a pattern. And the pattern is that whole combination thing. Pascal's triangle is a series of combinations that comes from this. Okay? And those combinations, 6 choose 3, the 5 choose 2s that we did at the beginning. And so that's what I'm going to set up for this. In order to find a specific combination, you need to know 2 things, or a specific coefficient. You need to know 2 things. What are the 2 things you need to know? First thing you need to know is you need to know what term it's going to be. And we're going to call that t. That's my term. And what else do we need to know? We need to know the power. All right? And the general formula for this is going to be P for my power, choose t minus 1. So whatever the term I'm looking for, subtract 1 from it. Next part is I'm going to take my a, and this can be raised to the power p minus t minus 1 times b raised to the power of t minus 1. So from here I just plug in and do what I know. I know that t in this one is equal to 4. I know that p in this one is equal to 10. And because I use t minus 1 so much, I'm going to take this a step further. I'm going to say that t minus 1, well, that's easy enough, is equal to 3. And now I plug in. P is 10. T minus 1 we said was 3. So it's 10 choose 3. A to the 10 minus t minus 1, which is 3, times b to the t minus 1, which we said was 3. So I go get my handy dandy calculator out. I do 10 choose 3. And ooh, what did I not do? Ooh. This is big. Looky. There was a negative there. So this needs to be negative b to the 3rd power, not just b. Okay? Because it needs to be plus a minus, right? Okay, so negative b to the third power. Again, I do this. 10 to the 10 choose 3 is 120. 120 times a negative 1. So this is negative 120. A to the 7th power, b to the 3rd power. And again, this question is only asking for the coefficient. So my coefficient is the number in front. So my answer for this one is a negative 120. I still want you to do it this way, right here, so that you can do this a one step. You can figure it out because they may ask you for the whole term later on instead of just the coefficient. All right, so let's see what's the next one. It says here, find the coefficient of the 5th term. Again, so 5th term. There's my t, and there's my power. So again, t is equal to 5. That means that t minus 1 is equal to 4. My power is equal to 8. And I just start plugging in. 8, choose t minus 1, which is 4. Okay, times a to the 8 minus t minus 1, which is 4. To the, again, negative b to the 4th power. Okay, to the t minus 1 power, which is 4. Okay, again, type in the calculator, beep, boop, 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 beep, and I find out this is the a sub 4, 70. A to the 4th power. Okay, and why is it just 70? Because this is to a positive exponent, so it's just going to be a positive 1 that goes out there. Again, coefficient is 70. There's my answer. Okay. Again, not too difficult. I'm just following an example. All right, so how can this get more difficult or more interesting? It's not really more difficult, as in they just change it up. So again, on this one here, there's my a, right? Plus a negative, so negative 4y, there's my b. But now they say, hey, find the coefficient of this one. How do I do that? The x to the 7th y term. Well, then I go and think about this. Hey, wait a second. That's why I wanted you to do it the whole way. Why? Because what do I know about this term? This one is a 1. But more importantly, if I go up and I take a look at my formula says that this is equal to t minus 1. So that means that t minus 1 is equal to 1. And what do I know about my power? My power is equal to 8. And now I just fill in. And so it's 8 over t minus 1, which is 1. A, so this a here is 3x to the power of 8 minus t minus 1 times my b, negative 4y, to the t minus 1 power. So what I find out is that, hey, 8 choose 1 is 8. 3 to the 7th power is a really big number. X to the 7th power, and look, negative to this, oh, so it's going to be negative. So that's what I can do. So when I plug this into my calculator, do 3 to the 7th power times 8, choose 1, which is 8, times a negative 4. I'm going to get negative 69,984. X to the 7th power, y to the 1st. So my coefficient is negative 69,984. Boom. Whew. All right. Last one. Okay. I don't think, let me take a look at it here. It's kind of the same deal. Okay. I'm just going to set up the basics of this so you can see again how this works. They're asking for x squared y to the 4th. They want this to be the t minus 1. That, remember, is equal to t minus 1. So t minus 1 is equal to 4. which means they're making us look for the fifth term. My P is 6, and I just fill it out real fast. 6 choose 4, all over to the x, or 2x, excuse me, to the 6 minus 4 power, times negative 3y to the 4th power. Again, I stick a lot of this into the calculator, find out what it is. I get 4,860 x squared y to the 4th. And this is equal to, so my coefficient is 4860. And there's my work. I'm sorry it was long, guys, but that gets you through it. The next one hopefully won't be as long, but I need you to get enough done so you guys could have some work tomorrow. See you guys tomorrow. Good luck. God bless. See ya.